Hello guys, welcome to Ramta Solutions and welcome to your grade 12 differentiation calculus past papers. Today the paper that we are looking at is the Western Cape's September 2024 paper. So before we proceed, let's remind you, perhaps let me zoom in the instructions quickly. I will not read all of them, but I want you to remember a few of the instructions. Okay, I want you to remember a few of the instructions here. I'm going to read instruction number 4. Is it number come on, buddy. Okay. Okay. Yes. Okay, it's instruction number 4, which says, clearly show all calculations, diagrams, and... Hey, come on. Clearly show... it's playing with me now. Okay, 65%, okay. Clearly show all calculations, diagrams, and graphs, etc. that you have used in determining your answers. Instruction number 5. Answers only will not necessarily be awarded full marks. Instruction number 7. If necessary, round off answers to 2 decimal places unless stated otherwise. I like saying, if you can, do not round off in the middle of your calculations. But if you want to round off, maybe make it about 5 decimal places. You will get the very same answer that your memo will give you. Okay. And then, of course, instruction number 10. Yeah. Our issue. Write neatly and legibly. We struggle with this one. Ne? But come on. We will improve. I get it, guys. All right. So, now let's get to our questions and ace this test. So let's see. Oh boy. Thank you. Now, let's see. All right. So, the reason I chose this paper is question 8 of the paper. Okay? Is question 8 of the paper. Okay. Maybe I should make it 62. Yeah, 62 for now would do. Okay. So, question 6. Now, 6.1. 6.1 says, determine f prime x from first principles if f of x, if f of x is equal to negative 3x squared plus 7. Alright? So guys, what you are expecting at the end of this question, whatever you are getting, f prime x should equal to negative 6x. You see, this is what I'm expecting from this is what I'm expecting at the end. But because we are using first principles, let's see what it will give us. But if it's correct, we are going to get f of x is equal to negative 6x. All right, let's dig in now. F of x plus h is, where there's x, you put x plus h. Oh, the stroke. Plus 7. So what is this? This is negative 3 into x plus 2xh plus h squared, right? Plus 7. So what is this? This is negative 3x, negative 6xh, negative 6xh, and negative 6xh minus 3h squared plus 7. Okay? Now, remember using first principles. This formula, guys, it's given in your formula sheet. Okay? It's given in your formula sheet. It's f prime x is equal to the limit as h tends to 0 of f of x of f of x plus h minus f of x all over h of, not h of, all over h of x, right? All over h of x. Okay. Now, substituting where there's x, we will put this. Okay. What is this? Sorry, we made a mistake here, guys. We're supposed to have said x squared. Okay. We're supposed to say x squared. Remember, this is the FOIL method of this guy. Okay, it's x squared plus 2xh plus h squared. So it's minus 3x squared. Thank you. So the limit as h tends to infinity, is it infinity? To 0. To 0 of negative 3x squared minus 6xh, right? Minus 6xh minus 3h squared, I believe, plus 7. Okay? Plus 7 minus negative 3x squared plus 7 all over h. Again, this is the limit as h tends to 0 of negative 6x squared. Maybe let's not even break this down. We can tell the negative 3x squareds are cancelling, or the 3x squareds are cancelling, and then the 7s are also cancelling. Therefore, we are left with negative 6xh minus 3h squared all over h. Now, our common factor, I do see a common factor. So our common factor will be h. Please don't say negative 3h, because the h will cancel with the h here. Okay? So it will be negative 6x minus 3h all over h. As you can see, they are nicely cancelling. We are left with the limit as h tends to 0 of negative 6x minus 3h. Now, what do we get? Now, because at this point, it is safe to substitute where there's h to put 0, it is safe. Now, when we do that, we drop the limit. So this becomes negative 6x minus 3 into 0. Okay? Minus 3 into 0, or times 0. So our answer is therefore negative 6x. Let's go back to check what I had said. It is indeed negative 6x. Right? So we are good to go. Okay, we are good to go. Guys, this is for 5 marks. So be careful there. All right, 5 marks, 5 minutes. And remember, if you are using a mobile device, please rotate your screen so to have a better view. And bear with me with these strokes, guys. Okay. 7.2.1, 7.2 says determine dy dx for each of the following. 7.2.1, y is equal to 8 square root of x minus 8 square root of x minus square root of 21. This is similar to saying y is equal to 8x to the power half minus square root of 21. Now dy dx, we can say it's 8 times half, which is 4, but let me not do that for now. I will say this is 8, you drop the power, okay? And then at the power original that you had, you minus 1, all right? And this one is a constant, you leave it like that, it's 0. Okay, so this is simply 4x to the, what is half minus 1? It's minus half, isn't it? It's minus half, all right? It's minus half. You can leave it here, you are good to go. 7.2.2, we have x squared. We have x squared y equals 2x cubed plus 4. Now we will divide by x squared throughout. So we have 2x cubed over x squared plus 4 over x squared. Okay, proceeding. This is then 2x. Okay, so y is equal to 2x plus, let's see, 4x to the negative 2. 4x to the negative 2. Okay, we good. Now we can say dy dx is what? I think you guys now have an idea of how we differentiate. So we'll just say this is 2 minus 8x to the minus 3. Remember, you drop the power here, and then you minus 1 from the power at the top, just like that. You are done. Okay, so this is your answer for this question. Okay, this is your answer for this question. Happy? Perfect. All right. Now let's see now for 4 marks, guys. Now 7.3, calculate the value of the constant h so that the curve of this guy will have a local maximum at this. That's okay. 7.3, so we say y is equal to hx plus x cubed. So we will say y prime or dy dx, let's just call it dy dx, is equal to x plus 3x squared. Now for it to have a maximum, we'll say 0 equals this guy plus this guy. However, maximum is at x equals -1. So what does it mean? We'll say h is equal, 0 is equal to h plus 3 into -1 squared. Right? Now, what is this? 0 is equal to h plus 3. So h equals -3. Isn't it? H is equal to -3. Okay. Perfect. Now, okay. Now, the reason we chose this question is because of the question 8. It's because of the question 8. Now, let's go. We were able to finish question 7 in less than 15 minutes. We finished it at about, 10 minutes, including with the yada. So you see, if you know your stuff, you will finish your exam on time. You will be able to ensure that those that you're struggling with, you have enough time to check on them, right? To check them up and try to see what you can do to get all your marks. All right. Now, question 8, the diagram below shows the curves of f of x is equal to ax cubed plus bx plus cx plus d, and then f prime x is equal to -3x squared plus 6x plus 9. The graph of f of x, which is that one here, it's given, intersects the x-axis at a and b. I can see that. D and E are the stationary points of the cubic graph f of x equals to this guy. -30 is the y-intercept of f. Okay, cool. Now the saying 8.2, this one, but it was an easy one. This one, they say, determine the coordinates of D and E. Show all your calculations. Remember, the x-coordinates of D and E, sorry, not just the coordinates, the x-coordinates of D and E. So the x-coordinates of D are the x-intercepts of the first derivative. So what is this? First derivative equals 0. Okay, so this is first derivative equals 0. So first derivative, first derivative equals 0. So what is our first derivative? It is negative 3x squared plus 6x plus 9. Bear with me, guys, with these strokes. Lately azilale. You see? 3x squared plus 6x plus 9 is equal to -3x squared plus 6x plus 9 is equal to 0. So we can divide throughout by -3. This is -2x minus 3 is equal to 0. So now we can factorize nicely. X minus 3 and then x minus 1 is equal to 0. However, then this part must be positive. All right? So what is this? X equals 3 or x equals -1. Okay? Moving on. This therefore means x of D must be the one that's negative. All right? As you can see, D is in the negative x-axis. So x of D is -1 and x of E is the one that is positive, which we said was 3. So x of E is 3. Then we are good. 8.3, for which values of x is f increasing, or rather determine the values of x for which f is increasing. As you move from wherever here to here, as x increases, y decreases. Oops, it's not. But from this point, point D to point E, as you move from the left to the right, x increases. And again, you can see the y values increase. So this is when x is greater than, the x value here is -1, but less than, the x value here is 3. This is when the function is increasing. To the right of point E, it is decreasing. To the left of point D, it's not increasing as well. It's decreasing. Right? It's a decreasing function. Okay. Perfect. 8.4, for which values of x is the for which values of x is the graph of this guy concave down? For it to be concave down, guys, for it to be concave down, it must be like this, right? So what you can do, you can say this is where the second derivative is less than 0. Okay, you can say this is where the second derivative is less than 0. Or you can say, for now, you can say this is where the midpoint, okay, this is where the midpoint of stationary points is less than 0 as well, right? It's less than 0 as well, right? But for now, let's take this one here, okay? Let's take this one here of the first derivative, right? So, second derivative, sorry. So what is our f of x? If you recall, did we find the equation of, oops, guys, we missed a question, all right? We missed 8.2. So since we missed 8.2, can we do it now before we proceed? We missed 8.2. We missed 8.2. Let's do it quickly. 8.2. We missed it. Let's fix it now. It is, what is it? 8.2 is, okay, we have f of x equals ax cubed, ax cubed plus bx squared. You might as well just ignore this for now. I will come back to it. Okay, but shouldn't, right? Oh yeah, let's ignore it for now. We'll come back to it. Plus bx squared plus cx plus d. Now, what is the first derivative? The first derivative of this guy, without the values, the first derivative of this guy is 3ax squared plus 2bx. And by the way, just to be sure, this will now become, it's the y-intercept. This point here is, check it out easily, it's the y-intercept, which is minus 30, okay, which is minus 30. So cool. So this is 3ax squared plus 2bx plus c. This is the first derivative. Now we do have, we are given f prime x is equal to negative 3x squared. Okay, it's negative 3x squared plus 6x plus 9, right? Plus 9. Oops. So what does this tell us? You can see this part here. Let me underline it. This part here is equal to this. This one here is equal to this one here. And then obviously, c is equal to the 9. Okay, now let's go. Easily, we say 3a is equal to negative 3. This implies a is equal to negative 1. Indeed, this a is negative, so it does show that it's gonna end with a frowning face. So we are good. Now let's go to b. We said 2b is equal to, let me go back, 2b is equal to positive 6, 2b is equal to positive 6. So this implies b is 3. Right? This implies b is equal to 3. Happy? B is equal to 3. And obviously c is equal to 9. Right? C is equal to 9. Therefore, we are good to say f of x is equal to negative x cubed, or as the value of a, negative x cubed plus 3b squared, not 3b squared, man, plus 3x squared, okay, plus 9x minus 30, right, minus 30. Then we are good. We just found the equation of f. Now, 8.3, which we did, I explained, you will remember. I said this is when x is greater than -1 but less than 3, all right? Because we are able to find the x values here, the x values of the x-intercepts, right? And these are the x values of the stationary point, isn't it? So we are good to go. 8.4, for which values of x is the graph concave down? So we will take the one where we say this guy, okay, where we will say this guy is less than 0, okay, where we will say this guy is less than 0, or you can use the midpoint of the 2, okay, you can use the midpoint of the 2, okay, you can use the midpoint of the 2, okay, midpoint of the 2, say, in this case, it must be greater than 0, okay, it must be greater than 0 for it to be concave up. If you use the midpoint, it must be greater than 0, okay. I repeat, if you're using the midpoint, it must be greater than 0. So x values of the midpoint must be greater than 0, or second derivative is less than 0. Let's see with the second derivative. So with the second derivative, we will say this then becomes, we can just determine the second derivative from the equation of the first derivative, which is -6x plus 6 is less than 0. So -6x is less than -6. Okay, let's go. Now what do we say? We say dividing throughout by 6, x will be greater than +1. So if you were using the midpoint, if you're using the midpoint of the x values of the stationary points, you're going to say it is greater than 0. All right, you're going to say it is greater than 0, and you're going to get the same answer. Okay, so we are good. Perfect. So this is your question 8. Okay, this is your question 8. Now let's have fun with the next question. Ooh, question 9. So question 9, let's see what it says. It says the flower pot below is in the shape of a cone. Remember guys, if you're using a mobile device, please rotate your screen. You will have better view. Okay, so the flower pot below is in the shape of a cone. R is the radius of the base and h is the perpendicular height of the cone. The slant height of the cone is 12 centimeters. The volume formula for the volume is these guys. Guys, this question wants you to choose which one is the proper area of the volume of the cone. It is not all of them. Okay, it is not all of them. So let's proceed. Show that the volume of the water needed to fill the entire flower pot can be expressed as volume is equal to 48 pi h minus 1/3 pi h squared. So we will say, with what I'm seeing here, I see that 12, 9.1. I see that 12 is equal to, another 12 squared is equal to r squared plus h squared. Of course, this is theorem of Pythagoras, right? This is theorem of Pythagoras, right? This is theorem of Pythagoras. Can't be writing one of them, This is theorem of Pythagoras. So what is this? 12 squared is 144. R, I do not know what it is. H squared, I leave it as it is. So this tells me that r squared is 144 minus h squared. To those that somehow struggle when we do this, guys, it's the same as saying 144 minus h squared is equal to r squared. Okay. Okay? Right. So the volume that we can use is this one here. Volume is equal to 1/3 pi r squared height. So where does what is this? Where does r squared we put? 144 minus h squared. Okay. So now what is 1/3 of 44? 1/3 of 144. 1/3 of 144 is 48. Okay, proceeding. This is V equals 48 pi h, isn't it? 48 pi h. And then what else do we have? 1 over 3 pi h cubed minus 1 over 3 pi h cubed. So we have proved this. We are good to go. Now, 9.2, the gardener wants to maximize the volume of water in the flower pot. Determine the value of H for which the volume is a maximum. So here we will use dV. As you can see, the volume formula varies with H. So we'll say dV dH. What is it? It is 48 pi minus pi h squared. Remember, guys, the 3 gets dropped. So 1 times 3, 1 over 3 times 3 becomes 1. Okay, so this now equates to 0. So this is 48 pi minus pi h squared. So pi h squared is equal to 48 pi. So h squared is equal to 48. H is equal to square root of 48. All right. Now, what is the square root of 48? The square root of 48 is 6.93. Okay? The square root of 48 is 6.93. H is equal to 6.93, which units? Centimeters. So, they said determine the value of H for which the volume is a maximum. The volume is a maximum when your H is 6.93. Remember, you could not get, let me see. So, yes, here you're going to get plus minus. So, because this is a measurement, you've never had someone at a negative 1.8 meters tall, right? We don't have negative height or negative length, okay? We don't have negative length. Hence, we can just leave it here and say this is the value of H for which the volume is a maximum. So, remember, guys, this is the best we can give you today. Okay, this is the best that we can give you today, and we hope that you ace your examinations and you make use of these videos to help you get those distinctions. So remember, if you would like to get in touch with us, visit our website www.ramtasolutions.co.za. So bye bye.